Today we're going to be reviewing interval notation and set notation to describe our domain and range of a graph. So I just want to go over some symbols and when to use interval notation versus set notation. You should be comfortable using both interval and set, but generally I will tell you to use whatever you feel more comfortable with. So in general, there are four symbols we use, and these are either, I'm going to call these hard brackets or open parentheses. And we can use a combination of them. They don't always have to, like the hard bracket doesn't always have to go with the hard bracket. The parentheses don't ever always have to go with the parentheses. So basically, well, now we need to know when do we use each one. So with the brackets, we're going to be using these when the values are included. And we'll talk about how to recognize that on the graph. But a good rule of thumb for this is if you see on the graph that you've got a closed dot, that's going to be a good indication that you want to use a hard bracket. When we use parentheses is we want to use when the values are not included. And a good rule of thumb for that would be if you see on your graph that you have an open dot or an open circle, that's going to be an indication that you want to use a parenthesis. And something to always keep in mind is also another thing about the parentheses is you always use with either the negative infinity or positive infinity. All right, so let's look at an example using interval notation, and then I'll go back to talk about set notation. So we want to describe the domain and the range of, we'll look at example 1. Just as kind of a review of domain and range quickly before we look at that graph actually, remember that your domain is your x values. And you always read the x values from the left to the right. And the range obviously is going to be the y values. And the y values are always going to be read from the bottom of the graph to the top of the graph. All right, so let's take a look at this graph here in example 1. So I know you can kind of see that a little bit clearer on your own papers. So in interval notation, again, we're looking for a domain. So we want the x values, we want to read them left to right. And I'm noticing that my furthest to the left x value here is at -6, and it's got a closed dot. So that means that my domain is starting at -6. And since it's closed, I'm going to go ahead and use the hard bracket. And then I'm going to put a comma and I'm going to read my graph. And I'm going to say, okay, where's my graph stopping? Well, it looks like my graph is stopping at +6. And again, that is a closed dot. So I'm going to put +6. And then since it's closed, I'm going to, again, use the hard bracket. So sometimes these might go with each other. They don't need to as kind of a rule of thumb, though. So the range, now we're looking at the y values, and we want to read from the bottom to the top of the graph. So it looks like the bottom y value is -7. And again, that is included because it's a closed dot. So I'm going to go ahead and put in a -7. I'm going to use, again, the hard bracket on that. I'm going to put a comma. And then I'm reading up to where my highest y value is, and my highest y value is at 4. And this is technically a closed dot here because there's obviously not an open dot there. So my range is from -7 included to +4, and that is also included. So I'm going to go ahead and close that with a hard bracket. All right, let's go over the interval notation for this one while we're looking at these examples. So the interval for domain, again, I'm looking for the furthest to the left x value. That looks like it's at -2. And all of this and this dot are both included. Obviously, they're both closed. So we're going to say that's from -2. And I'm going to read to the right here. Looks like my furthest to the right value is 2. Again, those values are included because they are closed. So I'm going to go ahead and use the hard brackets. And then the range, looks like my lowest y value here is -4, and it looks like my highest y value here is +4. And again, these are both included. So I'm going to write the range as -4 to +4. All Right, so that is kind of the deal with the interval notation. I'll turn over and look at the examples afterwards. I'll talk about set notation first, though, so I'll kind of go back up to the top here. So set notation looks definitely different than the interval notation. I think some people think this one's a little bit harder to write. It's really up to you of what you want to use, though. In pre-calculus and calculus, we generally work with interval notation. So I would definitely get comfortable using both, but generally I use interval notation. So the symbols that we use for set notation are a little bit different. We call these the curly brackets, and do your best to draw these. I know these are kind of hard to draw, but those are the symbols used always for set notation. There isn't different symbols depending on when values are included or not included. It's always going to be the curly brackets. So we write the domain and the range a little bit, it looks a little bit weird. So let's start with a domain. So if I were to write a domain of a function, I would start with my curly bracket. And then I'm going to write a couple symbols and I'll kind of write out what they mean. So I'm going to write out an X, I'm going to write out a vertical bar, I'm going to write out another X. I'm going to look like write a symbol that looks kind of like an E, and then hopefully you recognize that one as the real number symbol. And then after we write that, and you always write that for domain no matter what, there's going to be some sort of inequality here, which I'll talk about in a second. That's going to tell us which values are not included or included. So let me just get another color here. So the way that this is read, says X, and then that kind of vertical bar says such that. And this part just says X is an element of the real numbers. So that's read as X, such that X is an element of the real numbers. And then what is going to go here is going to be an inequality. That's going to tell us what values are included or not included. So just kind of keep in mind that the inequality with the equals to symbol underneath means that we're really working with a closed dot. And remember that the inequality without the equals to symbol really means that we're looking at an open dot. So that's the way that we would write the domain. And again, I'll walk you guys through some examples. The range is going to look pretty similar, but a little bit different because with the range, obviously, we're not working with X values, but the way that we write it is going to look similar. So it's going to be Y such that Y is an element of the real numbers. And then again, here would be the inequality that we'd want to use to determine what values are included or not included. So it's read the exact same way. It's read Y such that Y is an element of the real numbers. And again, here is going to be where your inequality is going to go. And sometimes there might be more than one inequality. We'll see that on the next page. So it might be like an inclusive inequality. It might be something that's like greater than or less than. It just really depends on what the graph is that we're given. So let's take a look at these examples and let's write these in set notation. So we'll go through these and then we'll turn over to the back and look at those examples together. So for graph number 1, the domain we said was from -6 to +6. So I'm going to write out my set notation. So my curly bracket, I'm going to write out X such that X is an element of the real numbers. And basically, since our X values are between -6 and +6, this is going to be kind of one of those double inequalities. I'm going to put -6 here, I'm going to put X in the middle, and I'm going to put +6 here. I'm going to close my curly bracket, and then I'm going to decide what symbols to put here. So since these are both hard brackets, that means that they're going to be included. So I'm going to go ahead and put my inequality symbols both facing the same way. So this is saying that X is -6 is less than or equal to X, which is less than or equal to 6. So our range is going to look pretty similar, except I'm going to use Y's now. So Y such that Y is an element of the real numbers. And now my range is between -7 and 4. Again, they're both included because I have the hard brackets. So it's going to be -7 less than or equal to Y less than or equal to 4. And I'm going to go ahead and close the curly bracket. So once you have the domain or range written out in intervals, that actually is pretty easy. And is this a function? Yes, it is. It passes the vertical line test. All right, let's look at this next example. So we have our domain and our range written out. Again, I'm just going to kind of set up my domain setup here, x such that x is an element of the real numbers. And again, -2 and +2, x is somewhere between there. And again, my hard brackets are going to indicate that I'm going to use the less than or equal to or greater than or equal to symbol. So it's saying that x is greater than or equal to -2, but x is still less than or equal to 2. And then the range, y such that y is an element of the real numbers. My y values are between -4 and 4. Again, hard bracket, so I'm going to go ahead and use the equals to. So -4 less than or equal to y less than or equal to 4. Close my curly brackets. This is not a function. It fails the vertical line test. If I were to pass the vertical line through there, my graph would obviously be hitting that more than once. So that makes it not a function. All right, let's look at a couple of more examples on the back. So these ones are a little bit different. I wanted to kind of throw some different scenarios in here for you guys to see. So for number 3, I'm looking at the interval notation for the domain. So I'm seeing that my leftmost x value is -3. This time I have an open circle, which means that my symbol is going to be different when I write my domain. So I'm starting at -3. And since there is an open circle here, I'm going to use the open parentheses. And then I'm going to put a comma, and my rightmost x value is a +1. And since it is included, it's got a closed dot. I'm going to go ahead and use the bracket for that one. The range is going to be from, let's see, the bottommost value is -4. And there is technically a closed dot here. There's also a closed dot here. So I'm going to use the hard bracket here. And then my highest y value is actually 0. So I know that this kind of looks a little bit weird because over here, this is technically a closed dot and over here is technically an open one, but the closed dot always trumps the open one. So even if you have an open circle here, the 0 is still included over here. So we also still want to include it in our range. So from here, I'm going to go ahead and write my set notation. So domain x such that x is an element of the real numbers. I'm going between -3 and 1. And my symbols are going to be a little bit different here. Since I have an open parenthesis here, I only want to use the symbol that does not have equals to underneath, because that symbol has to correspond to what you write in your inequality. For this part here, to include 1, this is where I'm going to use the less than or equal to symbol. So your symbols can be mixed and matched as well as like your bracket versus your open parenthesis. So for the range, this one's going to be pretty simple. Y such that y is an element of the real numbers. My range is going to be from -4 to 0. Oops. And this one, again, since I'm using both hard brackets here, I'm going to use the equals to symbol underneath here. And this is a function. It does pass the vertical line test. All right, the last one is a little bit different because you'll notice that there's an actual break in the graph. So the way that we denote that is actually with a U symbol. And that's called the union symbol. So that means that we're actually going to be reading two parts of our graph. So this part of our graph is going to have its own domain, and then this part of our graph is going to have its own domain, and then we're going to join them together using the U. So working left to right, so if I'm looking at what x value is going to be lowest, well, if this is going to continue up, my x values are actually going to keep on continuing to the left. So my domain is actually going to start at -infinity, because when I have an arrow here, it's really indicating that my graph is going to keep on growing. So there's not an x value that we're going to stop at. It's going to keep on going forever in the negative direction. So that's why we call that -infinity. Again, with the infinities, we always use the open parenthesis. So then I'm going to read, I'm going to say, okay, where is my x value ending? Well, it looks like it's ending at 2 with an open circle. So I'm going to go ahead and put my 2 here. Since it's open, I'm going to put another parenthesis. And this is going to be where I'd put the U, because this is going to be what joins this piece of my graph to this piece of my graph. So then I'm going to read this domain out on its own. So I'm going to pretend like this doesn't exist anymore for a second. So I just want to read this branch. So I'm starting from the left at 3. It is included because I have a closed dot. So I'm going to use a hard bracket. And it's continuing on, again, to positive infinity in this case, because when the arrow is there, it's indicating that the graph is going to keep on growing in the positive direction. So positive infinity, and again, with the infinity, I'm going to go ahead and use the open parenthesis there. For the range, I'm looking at the bottommost value here, so -8, and that is included because that's a closed dot. And then I'm looking to see, okay, well, what's my highest Y value? Well, here, my highest Y value, it looks like my graph is going to continue to grow upwards no matter what. So this is actually the range. It's going to be -8 to infinity. Again, infinity gets the open parenthesis. I know it seems weird because there is an open circle here, but where that open circle is actually is telling us that that value is included here and it's included here. So even though it's skipped on this part of our graph, it means that it is still included somewhere else. So we don't have to skip over it in the range because at that place, we have two other places to get that same Y value. So for set notation, since we're using the U, that's going to make our set notation look a little bit different, but I'm going to keep on using the curly bracket. I'm still going to set up that X such that X is an element of the real numbers. And what this is saying is that X can be less than 2, anything to the left of 2. So I'm going to actually write that as an inequality. X is less than 2. And it's just less than because the 2 is not included here. That's the parenthesis. And then I'm going to put a comma because there's another piece that I have to take into account. This is telling us that X could be anything greater than 3. And the 3 is included. So I'm going to write that as X could be greater than or equal to 3. And that's what's going to finish off my set notation. So when you have a U, you're going to have multiple pieces that you're going to need to write in your domain with the set notation. For the range, this one's pretty simple. So straightforward, Y such that Y is an element of the real numbers. And this is basically telling us that our range is starting at -8 and could be anything bigger than that. So in an inequality, that's telling us Y is greater than or equal to -8. And that's all I need to write because I don't have like an ending value here. The ending value is infinity. It's never stopping. And then is this a function? Yes, it is. It does pass the vertical line test. All right, so now it's your turn to try the homework. Please let me know if you have any questions or anything I can help you with.